In this video, I wanted to kind of summarize lecture 2, where we talked about voltage and current division. And I think the first point that I just want to say is that you can use resistor networks to do voltage or current division. And I think so this kind of gives you one of those electronic circuits in your toolkit, right? So remember, we were talking about a bag of electronic circuits which we can pick and choose to put together. So, so what this lecture did was it gave you one of those electronic circuits, an electronic circuit that can either divide voltage or divide current. So that's the first thing that we looked at. We also looked at the concept of loading, which is very important because even though we have these different electronic circuits that do different kinds of things. So, for example, you could have one electronic circuit that, let's say, does an addition between two voltages, V1 and V2, and then we put another voltage circuit that does division, like we looked at in this particular lecture. We would expect that the output would be something like V1 plus V2 over some constant A, but sometimes that's not the case because attaching these two circuits together, this circuit starts influencing the output of this circuit. And instead of getting uh, the outputs that we expect, we get slightly different things. And that phenomenon is called loading. And we looked at that and we saw how when you put two voltage dividers together, the output is not what we would expect but changes, and that's because they influence each other. So that's a very important concept to keep in mind, and we will talk about how we can work around loading in the subsequent lectures. But I think that's something that you can keep in your mind. So those are the two main things. But we also looked at some laws along the way, and I think the main ones were the Kirchhoff's laws that we saw. Now, Kirchhoff's laws are very important when we look at different electronic circuits, and we looked at something called the voltage law. So, which is we can call it Kirchhoff's voltage law. And Kirchhoff's voltage law states that when you go around a loop and you have several components that are connected in a loop, right? And you look at the voltage drops across each of these loops and add them up, they add up to zero. So summation of the voltage drops of across all components in a loop equal to zero. So that's the summation over a loop. The second law that we looked at was the current law. And the current law states that if there is a circuit, and if you have a circuit which is which has what we call a node, where you have two or more branches that are coming together, actually three or more branches that are coming together, then whatever current flows into the node also has to flow out, right? So if this current was I, this current was I1, and this current was I2, then we know that I has to be equal to I1 plus I2. That is basically the property of the fact that a node cannot act as a current sink. That is, it cannot take current and store it and keep it. So all the current that is coming into a node has to go out. What do I mean by node? A node is basically a point where more than three or more branches. Branches is basically paths for the current to flow, come and meet together. We also looked at very briefly Ohm's law. Okay, perhaps I didn't state it as Ohm's law, but Ohm's law is basically this relationship where you have between the voltage and current in a resistor, and we know that voltage is directly proportional to the current in the resistor, and the proportionality constant is what is called the resistance of the resistor. So those were the few things that we looked at in this lecture. We'll come back, and in the next lecture we'll look at op amps, and we'll see how op amps enable us to do many more interesting operations and make circuits that do more interesting mathematical operations.